Okay, so welcome and good evening to all of you. I'm Mila Stroganoff, your host and facilitator this evening, and the program's director for the Friends of San Pedro Valley Park. It's 7 o'clock and we're going to start. Please check the Friends website for recorded natural history webinars and activities pertaining to the Friends of San Pedro Valley Park in Pacifica. Our website, friendsofsanpedrovalleypark.org. Fairly straightforward. We have a terrific program ahead of us. Mystery, history, and adventure will be combined into a fascinating lecture. So stay with us and just hold on to your chair because we're going places. This lecture will be recorded, so in a week or two, we'll have it on our website. If you wish to watch it again, or if you haven't had a chance for whatever reason, missed this or had to get away. Anyway, it's going to be up. And please write questions in the Q&A section and comments in chat. That would be greatly appreciated. Questions will be taken at the end of the lecture. We'll take as many as time permits. And our upcoming program, oh yes, here's a little tidbit about what's coming up. It'll be with bird specialist Bob Lewis, entitled The Bird's Rainbow. He will unravel some of the mysteries of color in birds with a little chemistry, a bit of physics, and a lot of brightly colored and beautiful slides. He's an excellent photographer, so you shouldn't miss that one. This talk will take place on Tuesday, May 17th at 7 p.m. So do mark your calendars. And today we have the eminent anthropologist Mark Hylkema with us. He's a great favorite and we are thrilled to have him speak to us this evening. The program, as you well know, is entitled Mammoth in the Artichokes: Encounter with an Ice Age Landscape in Monterey County and Implications for the First Native Americans. Mark Hylkema manages cultural resources within 32 state parks of the Santa Cruz District, an area ranging from San Francisco to the Pajaro River. Mark also works on many other projects throughout the state and has over 40 years of experience in California archaeology with an emphasis on Native American culture. He has published extensively in journals and books focused on the archaeology of North America. In addition to his work for state parks, he is an adjunct professor of anthropology at Foothill College and has taught anthropology courses at Santa Clara University, University of California at Santa Cruz, De Anza College, Ohlone College, and Cabrillo College. Mark was the president of the Society for California Archaeology during the 2015-2016 term. And I am so delighted and pleased to hand this over to Mark Hylkema. Welcome.
Hello, everyone. Good evening. I hope you have good snacks and libations handy because I'm going to thread a story. It's a story of encounters that involved a lot of people and was a surprise, actually. I'm going to talk about our experience excavating a mammoth. We call it the Castroville mammoth. And the excavation work went on in the year 2011, and I'll walk you through that because in the course of working on this excavation of the mammoth, we also began to look into the relationship and the time periods that they represented in regards to the first Native Americans coming to the Americas and their origins here. So I want to share my screen with you momentarily and get my own self off the imagery and see if we can start with my slideshow here. Okay. There we go. Can you see that all right? There we go. So in the topic here is focused on where you see that red dot down in the center of the picture by Monterey Bay. That's the town of Castroville, California. It's at the mouth of the Salinas Valley near Highway 101. And it's a very quiet community, mostly agricultural in nature. In 2011, I received a phone call from one of our parks rangers whose family was leasing farmlands out in Castroville, and turned out the leasee, Martin Jefferson of the Jefferson family, was grading a nearby hillside to bring topsoil down to a lower elevation in order to plant artichokes. And in the process of grading, he noticed some bones in the grade of the excavator. And of course, he got out to check it out and found what could only be described as a tusk. And, you don't have to be a rocket scientist when you see something like this. The first thing you've got to, imagine is that it represents, something from another time, a very old time. And so in this image, you can see that we're clustered around the find of a tusk in the grade from the heavy earth moving equipment. It also went up the slope there. And all of that will figure into my discussion as we talk about the finds we made. So when heavy machinery encounters fossils in the ground, it doesn't look very pretty. In this particular case, you're looking at the tusk as it was exposed by the grader. And we soon realized that the ivory of a tusk grows in concentric rings, like growing circles within a tree rings and such. So when the grader hit it, a lot of the tiles exfoliated from the core of the tusk. So we knew that we had a mammoth by that point. It was pretty self-evident. Martin Jefferson, the farmer, also guided us over to another location nearby where a hole had been left from where he had extracted a tooth. And there was other scattered bits of bone that had been left by the grader. And you can see that the bone is in pretty good shape other than having been fragmented, but the condition of the bone is still good. It's not lithified. It hasn't turned to stone. So we looked at the tooth, and the first thing we noticed was that the enamel on the tooth had been worn down right down to the dentine, so that this must have been an older browsing animal. And we immediately began to exclaim, "Oh, look what we found, a woolly mammoth," because we're all a bunch of archaeologists, not paleontologists. And so we thought of, the Ice Age movie and cartoons and started envisioning woolly mammoths. And of course, it didn't take long for the more professional group of paleontologists to set us straight and inform us that this was not a woolly mammoth, it was a Columbian mammoth. Who knew? Evidently, there were several coexistent proboscideans or mammoth type creatures coexisting at the same time in the Americas. The Columbian mammoth was earlier than the woolly mammoth. And of course, the woolly mammoth, by virtue of being woolly, was further north where the ice fields were. So we looked at this tooth and we could see that the enamel had been worn down. So mammoths, like Columbian mammoths and woolly mammoths, are browsers. They munch on grass and graze like cows do. And so their teeth are grinding grasses, and you can see the enamel has ground down right to the base. So that indeed told us right away that it was an older individual. We were able to find the pieces and put them together and see that this was indeed a Columbian mammoth by nature of the teeth. And so this put us on a journey to try and discover, what this represented. So I began to call up many of my paleontological friends, particularly at UC Santa Cruz. And as it turns out, most of them were more interested in looking at ancient lizards and dinosaurs and such, and weren't that fascinated by what we call the Ice Age fauna of the Pleistocene. So we thought, well, what the heck? We're archaeologists. We know what we can do. And we decided to approach this excavation as archaeologists would, as though it was archaeofauna, like a kill site that Native Americans might leave behind. And we also harbored ideas and dreams of maybe finding evidence of first peoples, because we know in the archaeological record that ancient Native American communities did occupy the Americas towards the end of the Ice Age. So people have been here for a very long time, as I will discuss further. So we began to research what was involved with this animal, and that we had indeed a Columbian mammoth. And of course, like I said, we were quick to recognize our limitations between the differences between archaeologists and paleontologists. But if we grid this thing out, since no paleontologists were available, we thought we could expose the individual and recover it, with due record keeping and such. So that was our ambition, along with the possibility of finding perhaps evidence of ancient Native Americans associated with this, because this kind of animal was on the menu for first people. So we began to put a team together, myself, by virtue of default, because I was the one informed and became fascinated by the work. My colleague Dan Curley from Foothill College, now at Las Positas College, Dr. Timothy King, a very good friend who emerged from this project, was teaching at UC Berkeley and now is teaching at Foothill College. And I like what he has in his hand there. You'll notice the box, because the farmer became so enamored by the mammoth in his artichoke fields that he changed the label on his artichoke box. And on the side was a size scale from small, medium, large, and mammoth. Okay, we got a pretty good chuckle out of that. And I even saw this box on a shelf or on a pile at Whole Foods once. So mammoth artichokes, and duly named because that's where they were growing. Well, we needed a paleontologist. We realized that if we did find these kinds of fossils and they extended and became more extensive, that we should get paleontological advice. So we contacted the Page Museum of La Brea Tar Pit fame, and we eventually were able to attract the attention of this fellow, Trevor Valle. Trevor is quite an interesting fellow. He showed up at the site in the middle of the muddy fields with a black lacquered Hummer just spewing mud up in the air. And he came out with fossil tattoos on his shorts and his legs and everywhere else, and was quite a very fascinating fellow, very exotic. This project attracted more researchers and scientists, as I will tell. It's rather phenomenal and part of the story. The different characters and people that became involved just continued to grow as the project grew. And mind you, there was no funding for any of this. This is all volunteer effort and people just being enamored by the find. So the farmer too was enamored. He wanted to pursue his interests in grading and putting the soil back on, but he recognized the value of the find. So he volunteered to forego working here for a while, and he supplied a fence to protect the site from potential vandalism. I don't think that would have stopped too many thieves, but it was the gesture that counts. So we were able to put a fence up and secure the location and begin the excavations. Well, it wasn't too long when the rains hit, and this area got a lot of rain in that year. And the soil was probably the worst cement clay I've ever encountered in 40 years of archaeology. So that we could no longer access the site by vehicles. We had to hike in, and we had to leave our boots at the gates because they were caked with mud. And many of the crew were forced to work barefoot or in spare sneakers in order not to track the mud around. So it became logistically complex. And as we worked on the mammoth, we began to reflect on what it might represent. What was the landscape like? What were we dealing with here with the remains of this large proboscidean of the past? And so it took us places in our imaginations. I began to do research into early ancestral Native American presence in the Americas. And for lack of a better term, archaeologists coined those phases, that time, as Paleo-Indian time. I'm sure it's a lot more, in fact, I'm certain it's a lot more complicated than that, but we use those terms to designate a temporal span of time. Now, at the time first Native Americans came to this North and South America, there were these other species present from the Ice Age, along with the species we have today. For instance, mammoths. There was Bison antiguus, which was a much bigger buffalo type animal. There was the early horse, the dawn horse, Equus, here as well. Early camels too. There were broad-faced bears, and there were giant sloths, creatures that fit the Native American menu well. The environment was cool here, but it was not an ice sheet in the Monterey Bay, San Francisco Bay area. However, you have to recollect that because glacial ice was so thick in the Northern Hemisphere, sea level worldwide was considerably lower than it is now. Okay, this is one of the only charts I'm going to throw at you. It's a chart of oxygen isotopes from the ice sheets in Greenland, and what it reflects is climate change. And what you see is this bar graph where the end of the ice age is represented with the lower blue line, and then the advent of what we call the Holocene. We are living in the late Holocene now. So you can see how the ice age was moving along, and then it spikes around 12,700 to 10,800 BC or 14,000 BP. We see the climate suddenly spikes warm, and it's very abrupt. And one can call that cataclysmic environmental change. And soon it's followed by another cooling phase, only to spike up again and stay up. And as we all know, the climate is continuing to change today as it gets warmer. There was a phase where many animals dropped out of the equation at the end of the ice age. Many of the larger megafauna, as we call them, began to disappear. And it's about the same time that archaeologists proposed earlier, that first Native Americans are arriving. And so the conclusion was that Native people somehow extirpated, a lot of these animals as they hunted them. I don't follow that, because most of my knowledge of early hunting peoples is that they don't wipe out their food base and is quite diverse. So something else is going on. And now, as a spoiler alert, I will let you know that we know that people have been here a lot longer than that. So let's continue that discussion. But what we know about the Ice Age is that so much fresh water was locked up in glacial ice that sea level worldwide was 300 feet lower than it is today. So that has serious implications for where archaeologists might find some of the evidence of early people. It also created barriers and roadblocks for migrations of people, as we will see. So there were periods when these ice sheets opened and contracted and expanded. So there were periods that they opened long enough to let people through. But as we will see, the timing doesn't always jive with the archaeology. This is a graphic that represents how we know people traversed into the Americas. When during the Ice Age, sea level was lower, as I mentioned, so that many land masses were connected in the time that are now submerged today. For instance, Siberia and Alaska were connected for not a short time, but for many thousands of years. So this became a bridge, if you will, between continents that facilitated traffic between them of both animals and people. So when you look at a global level, what we see in this map, if you can squint and look closely, you will see the darker orange lines on the coastlines represents the paleo shorelines that humans would have known. And in it, you can see that England and France are connected as one land mass, and that New Guinea and Australia are connected, and that Thailand and Indonesia and Borneo are one land mass, as is Japan, connected to mainland of what today is China. And so too was Siberia, connected to Alaska. And so these are the landscapes familiar to paleo peoples, and is the way that people were able to migrate. However, I should point out that 50,000 years ago, people get to Australia, and the only way to get there was with boats. So we do see maritime technology pretty early on. In the Americas, we note the advent of early hunting cultures by the toolkits they leave behind, such as these very large bifacial tools, flakestone tools that you see in this picture. They are markers of the prey species they hunted. And it's clear that in early times, they hunted very large animals. So, I'm sorry, jumping around here. In the Americas, archaeologists were skeptical about when first people arrived, as new finds were occurring in France, in the Neanderthal Valley of Germany, and earlier human species were being uncovered, and some of them coeval with our species and modern species. There was desire to find where earliest people started, and a competition soon arose between Europe and America. And in America, archaeologists were unconvinced of earlier arrivals, and that colored their outlooks on ancestral Native Americans for many years, until 1908, when an African-American cowboy in New Mexico was minding cattle in an arroyo and saw where a washout had exposed a profile in the soil that contained many of what we would call fossils. And he couldn't help but notice that there were bones that looked like buffalo, but were much larger. And among them were stone tools. That word got out, but nobody believed it. And it wasn't until 1927 that an archaeological team went out to a place called Folsom, New Mexico, and indeed uncovered positive proof of humans and their affinity with megafauna from the Ice Age. And what you're looking at here is a point style called a Folsom point. And it's distinctive because of the flake scar that runs down the middle of it from the base nearly to the tip. It's very distinctive because it was a specialized tool for hunting these ancient bison. And there's an example of what bison antiguus looked like in the day, now extinct. So it wasn't too long thereafter, once archaeologists were clued in, that another find was made in New Mexico at a place called Clovis, where a mammoth was excavated, and in association were large spear points, such as this one. And what's distinctive about this is its size and the flake scar down the middle that does not run from stem to stern as the Folsom point did. So this point type has its own designation. It's called Clovis. The Clovis style point is older than Folsom by the magnitude of about 900 years, maybe 1,000 years. What's distinctive about Paleo-Indian technology is the fluting or the basal scar that runs up the middle. It's a very difficult thing to produce when chipping stone tools. And the craftsmanship that these ancient people had is manifest in the technology that maybe it takes an archaeologist to appreciate it, but if you try making these kinds of stone tools, you get a pretty good idea that these guys were very adept at their trade. I have to laugh. On our excavation, we attracted also a Disney illustrator named Josh Balsey. These are his illustrations. I think he got tired of drawing the more Bambi-esque type imagery of Disney, and he made pictures of a mastodon and a bear looking more ferocious than I think Disney would appreciate. But in any case, these were also specimens of bones or creatures that we found at our Castroville Mammoth site. So we soon realized that some of our bones were not mammoth. We had other species present as well, and including mastodon. I did not know then, but I know now that the differences in size, the mastodon is a little smaller than a mammoth, but it's also the difference in diet. A mammoth is a browser like a cow. It will chew grasses, whereas a mastodon is a leaf eater. It pulls leaves off the trees. And so its teeth have higher cusps on them to process the vegetation differently. And we found evidence of both at our Castroville Mammoth site. So I like this image. It's a made up image of a very fuzzy mastodon. Maybe someday we'll clone these guys and put bells around them and dog tags, and it might be pretty fun, although I'm not sure what the waste recovery bag might look like. But at any rate, with DNA and cloning going on like it is these days, it might be a future return. So when we look at the toolkits associated with Paleo Indians and the hunting of these creatures, we see they're quite specialized. And they tell us a story too of great mobility amongst people, because some of the chert sources or the flint sources for making these stone tools are at greater distance from where they're found archaeologically. And also the technology is pretty intense. These are large blades. In the upper left, you see the third one from the left. You'll notice these diagonal flake scars running up and down the side. That's called overshot flake reduction. That's where a stone tool worker will use a baton and smack the end of the blade and launch a flake all the way across the face and detach on the opposite side to thin the blade, so that the flake that detaches will have both blade margins represented on it. It's a very difficult technique to master. And in the Paleo-Indian sites of the Americas, we see the reduction sequences of making these points. Item B shows the overshot flaking, and then by C, they're fluting the base, and by D, they've finished it off. And so you see trajectories of manufacturing in the archaeological record. And they need these big honking points because they're going after big animals, ground sloths that stood 12 feet high. I have trouble wrapping my head around the image of a 12-foot high ground sloth. If you've ever seen one in a zoo, they're basically all neck, clinging from a tree, very, very slow. What did a 12-footer look like? We can only imagine. But they were on the menu for first ancestral Native Americans. I took this picture at the La Brea tar pits. Where else but down there can you get a mechanical saber-toothed cat trying to dive into a mechanical giant sloth with a mammoth in the background wisely looking on? I don't know why I threw that in the slideshow, except that it was amusing. But at the Page Museum at La Brea, we were able to learn about the animals we had found there. And we were able to identify some of our bones with their collections through comparative analysis. We soon found that we had ancient camel at our site in fragments, as well as the early horse, Equus occidentalis, which goes extinct. Both of them become extinct in the Americas, but are in the old world and probably migrated across the ice bridge, the Bering Straits, into the other way, just as the moose comes from Asia into the Americas. And so too did people. We also see that not all the big animals went extinct. There were also little ones, like this dwarf antelope was also on the extinction list. When we look at the archaeology of Clovis sites, we thought that that represented the earliest technology in the Americas, and that gave archaeologists a threshold of about 12,000 years ago for the earliest Clovis sites. But it didn't take long for other sites to pop up that were older still. And at first, they were very controversial because the archaeology of those kinds of sites can be very difficult. It can be very contentious to convince your scientific colleagues of the antiquity of things that change everything. And so those sites were contested, but now we know that indeed many of these sites are far older than we had anticipated, up to 18,000 and even 20,000 years old. In capping this, we also have sites all the way down in Chile that are coeval with the sites in North America, showing a very rapid populating of the Americas once it begins. So the problem is the timing. We know the ages when the ice sheets were closed and when they were open, and they don't jive with the archaeological record of Clovis and pre-Clovis sites. So there has to be another alternative explanation for how other peoples came in and how they came to occupy coastal America all the way to the tip of South America so quickly. Soon, a theory was proposed that people were going along the ice sheet on the coastline as a lineal route in boats. So the question arises naturally, what might those boats have been? And we can look at the ethnographic record of the North and see that boats were indeed known there and could have been known even earlier. For instance, this umiak is a skin boat made with walrus hides and seal hides stretched over driftwood frame and bone. So this umiak is capable of carrying a group of Eskimos offshore, and it's very likely that ancestral Native Americans from a much older time did the same. So adding to that concept was a find made by Dr. John Erlandson out on the Santa Rosa Island of Santa Barbara. There's a cave there And in the cave were deeply stratified sediments with shells that could be radiocarbon dated. And as they dated them from top to bottom, the dates got progressively older, till at the bottom, dates of 11,500 were developed. That's coeval with Clovis points and Paleo-Indian sites. And yet the projectile points are not Clovis, and indeed are dart tips that look a lot more familiar to sites on the eastern seaboard of Asia. And so some theories have been postulated that the coastal migrants carried that technology with them from their origins on the Asian coast. And I think what I'm trying to get at here is it's complicated. There is no simple explanation for the peopling of the Americas. And adding to the complexity is DNA analysis, which is now available as it was not before. And in a nutshell, because I'm not a geneticist and I don't want to butcher this too bad, I will summarize what I know, and that is that there are different alleles and different genetic strains in the Americas that show multiple migrations, not a single one. And more importantly, is we see that some of the groups that developed in the Americas thereafter also went back into Asia as well. So it's not a one-way street, it's a two-way street. This complicates things quite a bit. Adding to the complexity is now another theory where we notice that in the archaeology of Siberia and Asia, there are no large projectile point traditions like Clovis. And so Clovis and Folsom look like a North American invention. However, there are large blade assemblages in Paleolithic Europe. In Western Europe, particularly France and Spain, below their ice sheet, they get a large blade technology, oftentimes with basal fluting, and it's called the Solutrean period. It is the time when the last cave paintings are being made and greater complexity is occurring. But there is also an ice sheet that's going from England to Iceland to Greenland to North America. So if it's possible for people to migrate along the Pacific seaboard, it is possible for people to also migrate from the Atlantic seaboard as well. And so this creates quite a complex imagery. And I do not have the answer here. I am basically just sharing with you the beauty of how things are and how we are still trying to piece the greater picture of complexity together. And adding to this, of course, are the finds in South America. Recently, a very large panel of rock art was discovered in South America that depicts very vibrant pictures of extinct animals from that continent. So now that we are accepting the antiquity of people in the Americas, we are also now more cognizant of pushing the clock back. We will never know when first people arrive. We will only know when the oldest sites are dated. There is yet another possibility of people migrating over from the maritime across the Pacific. And it is possible that an errant boat or two could have migrated into the Americas as well. And so it is the DNA analysis that will help us sort these questions out about peoples and origins and movements. And that is still evolving. But by the end of the ice age, around 9,000, 10,000 years ago, the Earth's climate warms and sea level rises, and it creates cataclysmic environmental change as all the lowlands submerge. And it's during these times, as the Americas are disconnected from the old world, that we see people migrate to the various corners of the Americas. And here in North America alone, you can see so many different attributes of Native American cultures. It's a very vibrant place of many different people, so that you see the woman in the upper left, she's a Mojave woman from the Colorado River area. And to her right is a Hopi woman from the Pueblos of Arizona. And to the right of her is Ngloje Lota, a Red Cloud. He was a Sioux freedom fighter of his day. And to the lower left is a Nootka man from the Pacific Northwest with his riches, a big copper in his hand. And to the right is a Seminole woman from Florida. And so we see the diversity of peoples as they developed and mapped onto their habitats. But back to the Castroville mammoth, what did we find? Well, we began to look at this environment with those archaeological understandings in the background. And we began to think about this landscape as it was before. For instance, in this picture, you can see the Monterey Bay Marine Canyon is a very deep gorge. It's as deep as the Grand Canyon, and it rises up right to the gore point at Moss Landing at Elkhorn Slough. If you looked at the paleo map, when first people came, that orange colored line would have been the shoreline of the day. So the sea was about 3 miles away from today's shoreland at least. San Francisco Bay was an oak woodland valley, and people lived here then. So those sites are inundated and gone to us. We can't find those sites anymore. They've been gobbled up by environmental change. So we have to look to the inland areas for what might remain of ancient peoples. A friend of mine, Dr. Ivano Aiello, published this image, and it's a complex map, and I apologize for that. But what you're looking at is a coastline of Monterey Bay and the peninsula 12,000 years ago. The dotted line is today's coastline. The darker offshore is the coastline of first Native Americans. The Castroville Mammoth find is in the red circle. If you move the clock forward 4,000 years, 8,000 years ago, you see that there was an inlet of the sea, much like Tamales Bay, reaching all the way down to Soledad. And sea creatures would have been in there. It was a maritime environment. But the Castroville mammoth was preserved in the sediments of a much older deposit. So we began our excavation and we gridded off the site. We started exposing the bones and trying to stabilize them in position. It was very difficult because the ground was clay and adhering to the bones like cement. As Dr. Gary Brashini, he passed away a few years ago, a dear friend, too young. He was there photographing every bone as it was found because he too was hoping and anticipating, much like gold miners, looking for potentially a Paleo-Indian point embedded in this mammoth that would change the history of Monterey Bay. So we were very alert to that because we were approaching this as archaeologists. And as we exposed the bones and pedestaled them, we soon realized that it looked like this animal stepped on a Paleolithic landmine. It was all splattered and scattered and broken. And so we began to understand that this animal had been preserved in a wetland, a bog, on the edge of it. And it's very likely that very large other animals had stepped on the carcass and crunched it into bits. We basically found the upper third of this animal. And for those of our crew who became troublesome, we exiled them to the wet screens where it was difficult to remove the clay from the bone. That's my wife in the center picture there with her Aussie hat on. She's watching this, so now I'll hear about it, the fact that she was exiled to the screens, but we needed her to keep everyone moving. Being the project director, I had that authority. And this is what we were finding in the screens were these fragments of mammoth bone as they had been scattered by the bulldozer. This is a femoral head of a upper limb. It's quite large. It was bent like a pretzel. Clearly some very large heavyweight animal had stepped on it and crunched it. But it became a very useful item in identifying this animal's age. We were very good about keeping provenance on all the fragments as we uncovered them and by location relative to the excavation. We found another tooth, which is a bonus because we can learn a lot about the diet and the weaning habits of ancestral animals like mammoths through the dentition. And this is what the excavation looked like. You're looking at a scapula on the right and various other components. It's highly messy. We realized we were never going to glue this animal together again and stand him up in the Natural History Museum, but the data potential was large and became enlarged even more when we realized there were these fibers floating around the excavation that turned out to be the animal's hair. This is mammoth hair, and it was red, much like our golden retriever's color. So I can imagine herds of mammoth browsing on the hillsides, red like golden retrievers. But it began to oxidize rapidly in the sunlight as it was exposed. So we didn't know what to do. So standing around the artichokes, we called up the Getty Museum. Who else in Los Angeles? The Getty knows everything. And they responded surprisingly to us. And they suggested we get test tubes and helium. Well, none of that around the artichokes. So we sent Dr. Tim King into Prunedale to solve the problem. He quickly returned with mason jars and kids' party balloons with helium. and we were able to secure the hair. And as Tim says, we gathered enough to clog a drain, which gives you a graphic image of the amount. We contacted a geneticist, Stephen Schuster, who is quite famous in his works with Neanderthal genomes. And he happened to be in town, and yet another scientist dropping out of the sky. And he offered to check on the mammoth hair, and he positively identified it as Columbian mammoth. He tried dremeling into some of the bones to seek viable collagen for DNA sampling and was unable to succeed. But the effort was worth the price of admission for us. We learned a lot. As we exposed the remains, we began to tunnel more into the hillsides and to recover the bones as they submerged into it. And we found multiple strata represented. You can see a large band of darker sediment in the center of this picture. That turned out to be another fossil-bearing strata, to our surprise, with isolate animal bones well above the mammoth, so possibly the embankment to the bog where it had slid into. And in it, we found bones like this astragalus. This is an ankle bone to a mastodon, a young mastodon, as we soon learned. So the fossil finds continued. We also found other evidence, another mastodon element. We found a tooth of mastodon, which augmented and complemented the mammoth tooth. And then we found the million-dollar question. This is what I call the object. The archaeologists amongst us, as soon as this came out of the excavation, raised their eyebrows because it very closely resembles a broken awl, the kind of bone tool Native Americans used for processing things or for making basketry and such. Now, awls have distinctive wear patterns on their tips. So if it was used by a person, we might be able to identify that with a high-powered lens. And to our great fortune, again, more scientists dropped out of the clouds. Dr. Ivano Aiello, the man who made the graphic I showed earlier of the maps, showed out. Turned out he lived up the road and wanted to know what was going on. And he was a sedimentologist, is a sedimentologist at Moss Landing Marine Laboratories nearby. And also Jack Myers, who is a geomorphologist, a good friend of mine, showed up to study the land formations. Well, Ivano told us they have a brand new scanning electron microscope at Moss Landing, and did we want to use it? And of course, we all looked at each other and thought, sure. But none of us really had a clue on how to operate such a device. So Ivano took us in, and he offered to look at our bone object and examine the end to see if we could identify wear patterns on it. So he did that. This is a scanning electron microscope. It's on the left. And the little silver panels you see to the left of the computer screen on the device are the vacuum chambers where an object fits into. So it can only handle small things. It sucks the air out, creates a vacuum, is motion proof, and takes high resolution imagery of things like the tip of our bone object. So this is what it looked like. And in it, you can see that all the high facets are indeed ground down. They're rounded out from wear. And when we magnified it even further, you can see indeed that all the high facets are smooth. They should be sharper if it was an unused object. Of course, there's always the possibility that it had ground down in the soil. But then if that were true, that should be manifest on all the edges of the object. And so as a test, we decided to look at the opposite end where it was broken to see if any incisions could be found from, say, butchering with stone tools, or if any of the high facets were ground down there. If they had been ground down, we might have surmised that it was just tumbling in the sediments over many, many years. Well, instead, we found very sharp scars, very deep scarifications, and we magnified it even closer. It became very visible that there were a lot of striations on this object from handling and use, and possibly a butcher mark, which we magnified even further. This is the kind of scar that's left when a stone tool flake is drawn across a bone. So for us, it was like a smoking gun. But I soon learned in the contentious world of Paleo-Indian archaeology, if you don't find the projectile point stuck in the bone, you better have a good case for your argument. And we just didn't have enough. Enter the scene, another scientist, Dr. Tom Wake, a good friend of mine, happened to be traveling by, and he is the director of vertebrate zoology at UCLA, which is very handy. And he was interested in trying a technique for looking at microfaunal remains. We were looking at the macro, the larger stuff that we could see and excavate. He wanted to look at the micro, what might be found in the sediments on a much smaller scale. So he proceeded to do that. He soon found that by soaking sediments, the clays, in Clorox bleach, it would break up the particles, and he could wet screen it through fine mesh screen and recover a great deal. Among the things he recovered was a great deal of oyster shell. That's kind of a trick. The oyster shell was from a stratum. All of this was from a stratum just below the Mammoth. So it represents a time of a more marine habitat. And that provided a radiocarbon date. Tom was able to radiocarbon date the shell at 27,000 years ago. That means there was a paleo bay, an embayment there with marine species that later was covered over by a bog, a sediment package that contained the mammoth. So in other words, the mammoth post dates that event, which is very exciting. In the process of contacting the Getty, they became intrigued and decided to come out to help us extract the tusk, which was fragmenting as it dried out. They invented a technique of mixing toluene with latex and painting it on. When you do that, the toluene evaporates, leaving the latex embedded in the bone and seals it so that it's now an adhesive. So that facilitated our methodology for recovery. And they later went on to publish on that technique. More scientists just coming out of the blue. They invited us to the Getty, which we were quick to accept. And so we went to the Getty in Los Angeles to see how they do things. If there's a painting missing on the wall of the Rijksmuseum in Amsterdam, it's probably at the Getty getting fixed. If there's a piece of the Dead Sea Scrolls missing and being repaired, it's probably here getting fixed. They work on Egyptian mummies and all kinds of oddities that just had us enthralled. So we got to see what professionals do, and they were quite pleased to tour us around. On this opportunity of touring around the Getty, we also were able to join our partners at the Page Museum at La Brea Tar Pits. Well, nothing beats La Brea Tar Pits for Pleistocene fauna. So we were treated like VIPs. We were able to bring our bone specimens in for comparative analysis and get behind the scenes, so to speak. I don't know if you've ever been a tourist at La Brea. It's really cool to look through the window at the scientists working. It's much cooler to be on the other side of the window looking at the specimens. And so we were able to look at our mammoth and cite it and age it. She figured, the paleontologist there figured it was about 50 years old at the time of death. It was quite elderly. It was not a very big mammoth. It was somewhat stunted. And we were able to side the elements and know left from right and identify which parts we had. By that point, I drifted off so that I could look into the shelves of all the really cool fossil specimens that were just loaded everywhere, and quickly kind of realized that, what the heck, there's all these keystone species of the California landscape that are now gone. What was it like then, when they dragged seeds in their heavy fur from place to place from the weeds, and when they dug things up with their tusks and, aerated the soil and all the things they did. They were keystone species here for a very long time and then abruptly disappear. So where are the fossil finds in our Bay Area? Remember, the Bay didn't exist at that time. It was a valley and the coast was 3 miles out. That means the Farallon Islands were connected to the mainland. So the sites that would best inform us are inaccessible. But we do have finds. Other Columbian mammoth finds were exposed in a cliff erosion in Pacifica not too long after our work. And in Andy Nuevo, I've been able to identify mastodon bones and lately also fragments of mammoth. And then our Castroville mammoth find, of course, we had the horse, bison antiguus, Jefferson ground sloth, and other creatures as well. Another mammoth was found in the Guadalupe River a few years later. And then, of course, the Irvington district in Fremont. So the late Pleistocene fauna is characterized in two temporal phases. One is called Irvingtonian phase, and that went from about 1.8 million years to 300,000 years ago. And it's succeeded by a phase called Rancho La Brea, named after the tar pits. Rancho La Brea fauna goes right up until the end of the Ice Age, well into the time that first people are here. And the Irvingtonian phase is named after the Irvington district near Fremont, which I find very cool. Quite a few fossils were found there during developmental activities there for houses and freeways in the day. I also know that many fossils have been found near the Mountain View dumps along the Bay shore when excavations were going on for the foundations for the dumps and the landfills. Quite a large number of fossils were found there. So the moral of the story is we have a lot to learn still. And while we can push the clock back for Pleistocene animals, Rancho La Brea and Irvingtonian, we have yet to identify the oldest sites for ancient Native Americans. But we know that by 12,000 years, 11,000 years ago, they are in the Bay areas. And we have much older sites elsewhere. There's our happy crew, a lot of college kids getting the time of their life, getting the bragging rights of exposing a mammoth. We learned a lot, and we learned to be empathic with our find. I soon went to France to visit the caves to look at mammoths painted on walls, while my colleague Tim King and Trevor went off to were featured in a National Geographic special on mammoth and illegal ivory poaching in Siberia. You can look it up yourself and get a very good show. So that's the end of my talk. I just wanted to share with you my convoluted story. It goes on as we continue to study the bones. Right now, one of the teeth is at Cal State Chico, where Dr. Bartlink is studying the dentin, both for diet as well as for the weaning habits of raising the young. So the information continues. What hasn't continued is our publication. We need to wrap it up and publish. Okay, that's my story.
Well, that was fabulous. Absolutely fabulous. All right, let's see what we can. Well, let's check the questions. Let's see what's a cooking. Patricia is asking, is the fluting on the points for attaching the shaft or to aid in penetration or other?
That's a good question, and it's debatable. There have been bone sockets found that slide up the flute, and so these points are socketed. There's a shaft and a bone sleeve, and then the Clovis point will haft into that. And so there are other bone artifacts I didn't show in the presentation that speak to that. The question is, for instance, with the Folsom points, where the fluting goes to the length of the point, is that to like a fuller, like you see on swords and knives to help the bleeding? Because you have to also realize that getting that up close and personal and jamming a big animal with a pointed stick with a piece of stone on the end is going to really tick him off. And it's going to be dangerous. So there has to be quite a bit more to this story than we know. So the question is well made. If the hafting element of the spear progressed further up the point, it would give it more strength. I don't know the answer other than to say that it obviously served one of two purposes or both, facilitating bleeding of the animal and also strengthening the impact point.
Well, how many points, well, how many people would have to go after a mammoth in order to bring it down?
Well, we suspect that they're very small groups of people that are rather mobile. We don't see, archaeological visibility happens when landscapes become stable and you see repetitive use of a place. And then you get an archaeological assemblage of tools that can teach us about things. In the early Paleolithic times, people seem to be very mobile. You don't find, large deposits. They're moving around quite a bit. And what we do find in certain areas of the nation, there is repetitive visiting of the same places. And we do get accumulations of these Paleo-Indian points. A lot of them on the East Coast, as it turns out, as well as Texas, New Mexico, and Arizona. So any rate, we're looking at those relationships, and that information, is still, coming out. I kind of lost my thread there. But I did think of something else I wanted to add. I forgot to add too that recently, many of you may have seen in the news that in New Mexico, human footprints have been found in the muds there that are fossilized, and they're bending over aquatic plants that have been radiocarbon dated. Those dates have come out to be 23,000 years. So that is a huge find. Again, if we can accept all those finds, then again, we have just found yet another older site or evidence. But the assemblages people left behind speak of a highly mobile people moving around quite a bit. And we see that well into the early Holocene too, where archaic ancestral Native Americans, after the extinctions of these animals, are also largely mobile people, and sedentism begins to develop over time.
We have a question from Bevan in regards to the mammoth find in Pacifica.
Sure.
Where?
I can't give you a pinpoint, but it was in an erosional cliff, and some non-professionals, I could say we're non-professionals too. I'm an archaeologist, like I said, not a paleontologist, but at least I know method and technique. And we did encounter two individuals who had permission from a landowner to remove those fossils. They're not professionals. They did bring them to Foothill College, where we have the mammoth bones today, and allowed us to examine their finds. But they were possessive, so they're not in an institutional care. So we don't have a lot to say about those.
And if these fossils are removed incorrectly without cataloging the actual location well, and does it all fall to pieces in terms of scientific use?
Well, it compromises the kinds of questions you might answer. There are other questions that would be rendered from the bones themselves, of course. But context is everything in archaeology, the relationship of things to each other. A lot of paleontologists are more, I'm making generalism here and they can correct me, but a lot of times they're in the field to remove the specimen and take it to a lab more immediately where it's analyzed. In our case, we wanted to study the position of things in place. Because we're looking to see if it was a butchering site where bones are going to be dragged around or butchered. Some will be left behind, others will be removed to a campsite, for instance. So the position of the bones becomes important to us. So I don't know about the Pacifica finds, but one thing we can assume is that other finds must exist. But what's puzzling about the Pacifica finds is the elevation. If they're found in the cliffs, but sea level is 300 feet lower than it is now, how is it that they're up in the cliffs? Well, it's possible that uplift has occurred, or that landscape was an undulating hillside that went much further out in what is now the sea, that had little valleys in it with little ponds and bogs, and animals can get stuck in those places that are now truncated as cliffs and bisected by sea level rise. Oh, I see a note that somebody has said that they may be on exhibit at the Pacifica Museum. Is that right?
Yes, Deidre Crow says that that's where they are. Yes.
Oh, that's excellent. See, there you go. And then they'll be available, I hope, for specialists of the future, because, we may not know everything right now, right? But we need to have these objects for future reference as technology improves.
All right.
Sounds like your bells are ringing.
Oh, my clock. Yes. Yeah, my grandfather clock. Let me just, yeah, that's it. Okay. Robert is asking about, have you heard about mammoth tusks at Pillar Point?
At Pillar Point, I have not.
No.
We have found elements of mammoth tusk at Año Nuevo, so I wouldn't be surprised. Again, word of mouth tells you things. I'm not tied into any journals that would describe the finds. I haven't seen any publications that would help me from the area. Well, we have our incidental finds, word of mouth. And so I think the onus is on our team to write up our find, even if it is more of a story rather than a scientific document. It is both, actually. We should tell that story so that as other people make finds, they can plug into it. We have seen our information, as it's been popularly presented by the press, show up in journals all the way in Europe. I have shared the imagery of the bone object, as I call it, with colleagues in Europe, and they've run with it in their publications, which pleases me to no end, actually. Because
sure
again,
would, yes.
it's quite a story. Again, all these scientists and specialists just floating in, word of mouth, really.
They gravitate, don't they? They just
Well,
like,
it's like the Woodstock of mammoths here. And what particularly was kind of sad too is one of my Native American friends said, "Wow, look at all the help you got on that. You know, we don't usually get that on our projects," which is true.
bit of bitterness there, to say the least. Yes.
Yeah, you know, I mean, I think we're all enamored by the mammoths. They're very intriguing, and I am too, I got to admit. But I have been working with Native American ancestral sites all my life and have learned to respect, you know, their relationship to the lands and the evolution that goes on. And of course, many of the people will tell you, we didn't come from anywhere, we came from here. And as we push the clock back, that may well prove to be true, who knows?
Well,
But it doesn't.
you have a student, sorry, you have a student, Kay Lynn, who is fascinated. She says it's a fascinating look at our local and regional archaeology. And Mark, as a former student in your classes at Foothill, have you considered resuming or plan to resume teaching there?
Well, that's a loaded question. I have been asked. I mean, I'm retiring as of June 1 from 33 years of state park service. I love my job, but I'm taking care of elderly parents now. And I plan to consult, and Foothill has asked me to resume teaching, and maybe I'll say that. But
anything's possible, right?
well, yeah, I have to retire so I can get to work. I have a lot to do.
And Ken is asking, what's your opinion of the Mammoth rubbing rocks up at Point Reyes?
Okay, that's something I'm familiar with. Another archaeologist friend of mine, Breck Parkman, former state parks archaeologist, was working up by Salt Point, further up the coast, where are these rocks that stand straight up. They're marine rocks on the coastal plain and terrace. If you've been up there, you might have seen them. Well, he noticed that some of the Franciscan chert, which is a flint exposed in the rock, was worn and polished. So he created a hypothesis that maybe those were rubbing rocks for mammoths. And we have to recall that many of these features of our land were there, and for the mammoths time as well, and are deep in time. And so he postulated, much like African elephants will come to termite hills and trees and rocks and will rub on them for scratching. He postulated that that might have been the case for these stones to explain the wear patterns higher up on these pillars. And of course, it's conjectural. He did an excavation at the base of the rocks, hoping to find what we found, which was the hair, and was unsuccessful, but that doesn't preclude the possibility.
Now, with the shape of the mammoths, they have this very large head. They have this hump on the back of their backs, and it's completely different from our recent elephants. What is precisely up there?
Well, brain, large brain capacity, a lot of fat. And beyond that, I'm not sure because I've never dissected one. But you're right, the mammoths, both Columbian and woolly mammoths, have a vaulted cranial capacity. They're higher, and that's one of the distinguishing characteristics. Its function is unknown to me. The hump on the back is not actually a hump. That's a vertebrae. It's its backbone. And if you look at modern elephants, you'll see they have the same curvature, actually, are very similar.
But not as large a curvature?
Well, you can get some pretty big, African elephants. They're pretty big. A Columbian mammoth stood about 12 foot high at the shoulder and would have been comparative in size, whereas the mastodon is a little shorter. And there were isolate mammoth populations that held out after the Ice Age, there was a group of mammoths on the Channel Islands that became smaller. They're called pygmy mammoths, and they were there till about 6,000 years ago, which is well into Native American times. We also have mammoths holding out on the Bering Islands in the Bering Straits. And more recently, I've read articles in the past, just the past few months, of geneticists looking for DNA of ancient animals in the far north and finding it in contexts that are much more recent. So it's possible that mammoths continue to hold out in the far north as, up till 7,000 years ago. Okay, there's still a long time for you and I, but 6,000 years ago, you start seeing the formation of the ancient Egyptian empires, if you want to put it into a cultural context. There's literature in those days, so it's interesting to put it in a temporal scheme.
And the smaller pygmy mammoth that was found on the Channel Islands is now located in which museum? Do you happen to know?
I don't know. I'd imagine the Santa Barbara Museum of Natural History would be a good place to look. Yeah, and the Page Museum. Nothing beats the La Brea tar pits. Boy, I certainly enjoyed our VIP tour of the tar pits. It was extremely fascinating. And they're excavating more as new developments are going on around the park and exposing more, finds, very large fossil finds.
Yeah, I mean, that is one fascinating location. I mean, you can just live there for a year, just walking around looking, and if you can even get behind the scenes, then you want to open all the drawers and just look at everything. And
I think it's like I was saying, it's the light bulb that goes off in your head. If you're a naturalist and you like hiking around, it's almost hard to envision, that landscape of, geologically, it's just a flash in the pan ago. It's not that long ago. It's long to us, but those animals were here for a very long time, on the span of like a couple million years at least, right? And then abruptly, some 32 species of large mammals disappear. And so the causes are what we're interested in now. People did not hunt all these animals out from North America to the tip of South America. That's just not likely. So what explanations might there be? We do find the toolkits associated with butchering them for sure. High meat yield, it takes one mammoth to offset 100 rabbits, I expect at least. So the reward for the energy involved is high. The risk is high too. But what caused the extinction of animals like the dwarf antelope, which certainly wasn't a big meat producer? How do we explain that? And I think that's where the questions are.
So the Native Americans, well, I mean, yes, they obviously hunted mammoths, but in terms of their main choice of diet, or what would be easier to bring down, what did they go for? I mean, since there was such a huge variety of species.
Well, and that's a good question. And when we did the microfauna, I forgot to add the microfauna that Tom Wake did, produced, salamanders, snakes, fish bones, all the little species that gave us a better picture of the environment of the mammoth of the time. And what it speaks to is a wide diversity of animals were present. All of the animals we see today were there then. So why did people, that's another question actually. Archaeology is full of questions. Why did they focus so heavily on these large animals when making a rabbit net might have been, less energy intense? Well, the reasons are in the evidence. Clearly they made that choice, and they chose it for reasons that we have yet to uncover. It's probably because of the high fat yield inside the marrow and the bones. It's possibly for the hides, the large skins that they could pull off. For clothing, we do find bone needles in Paleo-Indian sites too, with eyes in the end, eye holes like our needles, which would suggest clothing and stitching. We do find plant residues, particularly on the East Coast Paleo-Indian sites from Florida, up to the Carolinas. There are quite a few Paleo-Indian kill sites that are recorded. And in them, we see other animals like deer, elk, buffalo. So the answer to that question is their diet then and more recently was diverse. And their selections were made for reasons that we may not understand.
It's always amazing to see how these very large animals, then and now, and in the oceans, always eat the very, at the very base of the food chain, which was always something that astonished me. And I said, how in the world did they gain enough food from
Right.
that? But, it's just, how do they gain enough energy from eating that? But sure enough, it's not the top of the food chain, they eat at the bottom.
Yeah, and so I think we cross paths with many disciplines. We have archaeology, paleontology, animal biology involved, the faunal studies. And so, it turned out to be, for us, a very educational project, educating the educators, and we're still learning.
And Adrian wants to know, is there still work being done at the Castroville site? Or is
No, it's
No?
gone back to artichokes. We found that the mammoths, the bones that we were finding in the hillside nearby were isolated elements. They weren't articulated together like the mammoth was. And so it was like a giant box of Kleenex. You pull one out, there's another behind it. And so we kept excavating and finding isolate loose bones. And then we realized we got to stop, And so we basically just stopped and realized that we had plenty to work with. And what we have out there, as the title of my talk is an Ice Age landscape. And in that landscape are contained those stories of those animals of the past. It was not restricted to a single location. It was spread out throughout a larger landscape.
And the farmer wanted his land back too, probably for planting.
Certainly, they were very congenial, pleasant to work with. We all had a great time. But the landowner, they rented, and the landowner, I've been in contact with, again, as a matter of fact, just today, as fate would have it. And we are both talking about retirement and maybe kicking around out there and seeing what we might do. Part two.
Part two. And the story continues.
This one won't end, I think.
Well, let me just check, but I think let me just check chat, just in case. Okay. Let's see, okay, just so that. All right, well.
Okay.
I think we've gotten everybody. So, Mark, thank you so much. It was just absolutely a fantastic evening.
My pleasure, and feel free to ask. I have other stories.
So. Oh, we'll have you back. Believe you me, we'll have you back if you're only willing and wanting.
All righty. Well, good night, everyone. Thank you.
Take care and good night and many thanks.
Bye-bye.
Okay, so that's